Okay, let me know if you have any difficulty seeing me or seeing the board or anything, okay? Because I have to set this up from scratch every time we have lecture. I think Gabriel said that it would be best if you could hand in the homework on Canvas. I heard that some countries, I mean, maybe China, that Canvas is not available. So, you know, if for whatever reason Canvas doesn't work for you, just hand it in, you know, through email or whatever, that's fine. Usually, you know, if you're taking pictures of things, there's some apps. You know what, I don't actually know the name of them because I haven't tried it out, but I heard there's some good scanning apps. Does anybody know the name of a good scanning app? Because I think if you use one of the scanning apps, instead of uploading pictures, it's easier to make like PDF files and they're not as big. So it might be easier for you to upload to Canvas. I'll try to find the name of a good scanning app so that we can do it that way. Okay, and then the other thing is I uploaded the data. Oh, okay, so here on the chat, I don't know if everybody can see the chat, but there's, you know, some people suggested scanning apps here. So Scanner Pro, Genius Scan, or the Notes app, okay, on the iPhone. So those are all different scanning apps that you can try out. Well, you only need one, but hopefully, and you know, you can send pictures or whatever, but I think that they're just bigger files, so it's a little bit harder to do it. So it might just be easier to use a scanning app. All right, and I uploaded also the midterm project data set. So remember, instead of the second midterm, we're having a project. And the project, I envision it as being like a short paper. So maybe like 5 pages if you want to do single space, or maybe 10 pages if you want to do double space, but somewhere in that range. I mean, the length is not the most important thing. I suggested kind of an outline to follow, you know, because there's usually kind of a standard format for research papers. It's normally, I mean, you can deviate some if you want, but usually it's like an introduction. And the intro gives like background on the question, you know, so in this paper, we're looking at the difference between different types of schools. So there's a regular school where you would go in person, and then there's telesecondary school where they go to the school, but they receive their instruction over video at the school. Okay, and we're going to be looking at, is telesecondary as good as going to regular school? Okay, and I gave you data on students that have the choice to go to either type of school. And then you also have the data on like the distance they have to travel to get to the school. So intro normally gives an introduction, and it also, it says, you know, what is your research question? So question of interest. Usually it provides a little bit of lit review, although sometimes people, if they have a lot of literature review, they might do a separate section of the paper on lit review. And then, so the difference between like a research paper and a, say, like a creative writing or an English type of assignment, in English sometimes, you know, if you're doing more creative writing, you don't tell people up front, you know, what your results are. But like you might have a thesis statement, but you don't really give it all away. Well, for a research paper, you do kind of give it all away, you know, like in the introduction, you say what your findings are, because the intro should be kind of, you know, introduction, laying out the methodology you use, talking about the data set you use, the modeling you use. Yeah, so the preview of research, like modeling, estimation method to use. Well, actually, let me write those as separate sections. So you normally would say, like, what type of model are you using? So that would be the Roy model. You know, I asked you to, but I think you should also do some descriptive analysis in the paper, like not just the Roy model. You know, you have this data, it's actually brand new data. Nobody's analyzed this data. Like nobody's actually looked at this question with these data because we just got these data from the Mexican government. So they're actually, you know, better data than a lot of the existing papers have used. So it's actually exciting for me, you know, to be able to, like, for the first time work with these data, because Gabriel's been cleaning the data for a long time, trying to prepare it to be able to use. Like she's using it for a dissertation, you know. So this is a research project. It's actually original research, right? I don't know what the answer to the question is or what your findings will be, okay? So in the intro, you would normally say the model you're using, the estimation method. You know, so the estimation method is basically like this control function approach that we've been talking about the last few lectures. And then you normally give some discussion of what your key findings are. You know, so maybe I suspect you'll find that different types of families go to the telesecondary versus the regular school. Like, you know, I'm guessing, but I don't know if this is true, but probably kids from poor families might go to the telesecondary, you know, or maybe one type of school makes it easier to combine working and school, you know, but you have to look what types of families go to different schools. Okay, and then what the key results are. And then, but the other sections, since this is all in the intro, this is going to be kind of just a few sentences about it. You know, and in the other sections, you would go into detail, like about the model where you actually explain, this is the model you're doing, this is the estimation method where you actually give equations. Then, you know, you'd have a data, like empirical analysis results. Okay, and that would be descriptive evidence. So you could do like, you know, plots of test scores for different kinds of kids, or if you think differences by gender is important, or differences by family background. So whatever you think is important, you know, so this is a chance for you to like do some creative thinking, you know, and I'm going to grade these papers, you know, just as if I were grading just a research project, you know, and research projects can be different. It's not like everybody has to get the same answer. You know, I just want to see the quality of the evidence that you present, and you know, I'll just judge the paper about how you present it, you know, how you draw your conclusions, you know, whether you discuss nicely what the results are, or what's statistically significant, things like that. So it's not that there's a right answer or a wrong answer. You can kind of go different directions depending on what you think is most important. Okay. So there's like the model section, the data section, and then, well, you could have a separate lit review section if you wanted to, like if you wanted, so I'll put this like a question mark, because sometimes people, you know, you can look at other papers to get an idea about how they're organized, but this is kind of a standard organization approach, you know, and then here you'd have descriptive, and then you'd also have the modeling results. You know, so that would be the estimation. So if you do a Roy model, you should have the binary choice model, and you should also have the regression models, you know. And then I said, I'm going to talk a little bit today because I asked you to look at like treatment on the treated, treatment on the untreated. So I'll kind of go over today, you know, what kind of model I'm expecting. And then finally, you know, normally you have a short conclusion section. And since this is just a short paper, I'm not expecting, you know, huge amounts for each of these things. So just, you know, the conclusions can be like 1 or 2 paragraphs. Doesn't have to be a big thing. So the most important, you know, that you just kind of present some results, and so this is going to give you a chance to work with data and to think through yourself, you know, what's important to present about the data. And you'll have math test scores and Spanish scores. You can analyze them separately if you like, or you could combine them. Okay, the fourth problem set, I'm going to give that as soon as possible, actually. So, because I want to give you enough time to work on it. I mean, basically, in terms of topics we have to cover, I'm going to cover labor supply models, which probably today and next class. And then after that, I wanted to cover a little bit about non-parametric estimation. So the fourth problem set, I'll try to give it to you early, but we may not have gone over all the topics. Okay, so I will try to get it to you. I know that, you know, some of you are celebrating holidays. I think there's like Passover, there's Easter. Yeah, I would normally celebrate Easter except with this disaster. Like I can't really go visit any of my relatives, so I'll just be here. But you know, in case you do celebrate some of these holidays, I wanted to give you the problem set with enough time so that you can do it, you know. But it'll be due, the problem set is due at the end, like last, I think the 428 might be around the last day of class or close to last day. And then also the paper will be due around that time too. And then we will have a final. I'm still trying to figure out exactly how to time the final. It'll either be 24-hour or else it'll be a thing where you like log in and you have a certain amount of time to finish it. You know, but I want to practice with the software, like to make sure we don't have any glitches. You know, so because if we do this time test, you know, it might be hard to log in or something like that, and I have to make sure all this stuff works. Or maybe we might even do like a practice run, like to make sure that it works so that you're not like stressed and trying to get the software to work like on the day of the final or something. So I will give you more info about that. But basically this short paper and the problem set would be due like the last day of class around. Okay, could we compile the results of the class? Oh yeah, definitely. So we can share the papers. I could make a website. You know, I'll get your permission before uploading any papers, but if you wish to share your paper, I think that would be really nice if we could, you know, share at least among the class members what the results are, and you can see how similar, you know, because I'm hoping you can work on the papers independently, you know, because you can kind of go in somewhat different directions a little bit, depending on what control variables, you know, so it'll be a good thing to see like what the sensitivity of the results are to different modeling assumptions. Yeah, the length is about 5 single space and up to 10 double space. So definitely kind of, you know, the model that you write down and interpreting the estimates is going to be the more important thing. Okay, so I don't expect you to write like a very long lit review. I put some papers on there. It's not that I expect you to study the papers in detail. The papers I put on there are more like maybe some valuable background reading, because they're not exactly what I'm expecting you to do. There are only 2 papers on this topic, like comparing the TELUS secondary school to the regular school. There were 2 papers, and I think they were both written by grad students. One was on the job market last year from Northwestern, and the other one, I don't even know if the other person was on the job market at all, because the paper is kind of incomplete. Like you'll see it says like do not cite, which means it's pretty preliminary. And those papers did not have the data that we have. Okay, so I think one of the papers used more aggregated data. So I only included those things because I thought they might have a good discussion about how those schools are, you know, just some information about those schools. Because this is actually a very interesting question, because there are many, many countries where education is not provided, you know, especially to people in rural areas. You know, like all over Africa, they have problems with schools that are, like they might have a few schools, but kids have to travel very long distances. And sometimes they don't have electrification at the schools. They don't have computers. They may not even have lights, you know, so kids have a hard time studying at night. Because last year we interviewed somebody on the job market who was studying giving solar lighting to schools in Africa. And then sometimes they might have 100 kids per class, you know, because there are not enough schools. So providing education through like video, you know, in Mexico, it's kind of one of the leaders in this. There aren't that many countries that do this, like video education. But Mexico has been doing this big time, especially in some rural areas. That's the only kind of education available. Okay, and even in Mexico City, some kids get over video because there aren't enough high schools for everybody to have a spot. Right here, you kind of take for granted that there's always some school you can go to. I mean, I guess there are some people that live, like, I visited some islands in the Chesapeake Bay that are pretty kind of far out in the water, you know, and they don't have a high school, you know, but I think they send kids by boat to the mainland. So even in the US, there's some remote areas. Okay, so it's an interesting question, actually, from a world perspective, and Mexico's one of the leaders in providing this type of education. And, you know, I know a guy who was a subsecretary of high school education in Mexico. He actually has a PhD in economics. And he told me that, you know, in contexts where the teachers aren't very well qualified, the video education may actually be better, you know, because at least you have teachers that know what they're talking about teaching the material. Okay, so it's not entirely clear like whether regular school would be better than the video, right? So so it is interesting problem. Okay, let's see. Yeah, so definitely if you give permission, no, so the tables, figures, bibliography would not count towards the page count, you know, so you can add additional tables. You should have a bibliography, you know, referencing papers, but I'm not expecting you to like go outside the papers I gave you, you know, and you don't even have to study all the papers I gave you. I mean, I gave you one paper applies the Roy model, you know, but they apply it with Chilean data, and they're looking at the decision to choose. That's the paper by Sapelli and Vial. Okay, so I thought that would be helpful mainly because the model is similar, but it's not about this telesecondary. And then I gave you two papers, which is about these telesecondary schools. So that's more just background to know more about these schools. And maybe it gives you a better idea of what control variables would be good to put in your model. Then I gave you a paper that I wrote a while ago with Ken Wolpen, and it's about estimating what are called educational production functions. Okay, and this educational production functions are these equations for test scores, like current test scores related to lag test scores. They're called value-added models. I think I talked a little bit in class about them because they're used even to evaluate teachers, like value-added models. So we're just talking about this general literature, like how you specify these equations, what variables should be included in the model. So let me just, yeah, there was a question that came up, which I think probably everybody might have this question. So normally, let's say you have test score in grade 7. Well, let me call it T, since it's test score of child I in grade 7, okay? And let's say that child is in some school. And that could be a test score of the same child in grade 6. So that would be like math tests. So this is how much additional learning did they do? Then normally you would have some characteristics of the child's family, you know, because children, if your mom and dad have more education, they're probably able to help you in school. You know, they might hire tutors for you, things like that. So your parents' background, or even like whether you have a computer at home, that might influence your learning. And then you could also think about including school characteristics, okay? So you would think that the school characteristic would matter, okay? But in this project, I did not give you this, okay? So the reason I didn't give you this is we're just gonna say, you know, that the school characteristic is gonna be type of school. So that's captured by the fact that you have a separate equation for the telesecondary versus the not telesecondary, right? Because you're gonna have like, all of these are gonna be, say, tele, and then I think I said sector 1 is tele and sector 0 is regular school. Okay, so you're gonna have like a whole separate equation for each type of school. So this is like regular. Okay, and this is like tele, and then you've got regular. Okay. Because we could put in school characteristics, like suppose the teachers are better qualified, you know, in one type of school versus another. But if you put in school characteristics, it would make it kind of complicated to figure out the treatment effects. Okay, so that's why I didn't give you school characteristics. We're just gonna say, you know, if you have separate coefficients for the two types of schools, that's going to reflect the differences in the school, like including the intercept. So you won't have to like figure out if the schools are different, why are they different, you know, because it would just require a lot more analysis. You know, probably if you find that one type is better than another, then it would be useful to relate it to school characteristics to go further to figure out like why is one type better, you know, but I didn't expect you to do that, you know, in 1 month it's already, you know, it's a pretty big project for just doing in 1 month, so. Okay, so so don't worry about that. Like in this paper, we argue that you would normally have family background. This is the Todd and Wolpen paper in 2003. Okay, and we argue that you would put like family background and school characteristics, but the way we're putting school characteristics is we're just gonna have separate equations for the different types of schools. Okay. All right, so, you know, if you have questions as you work on the project, if you post to Piazza, I'll try to answer the question so everybody can see it. Let's see. No, so they did not face this choice. Okay, that's a good question. So they have choice between telesecondary and regular school in grade 7. They also have that choice in high school. They did not have the choice in primary school because there are way more primary schools than there are middle schools. It's kind of similar in the US. You know, grades 1 through 6 are typically smaller schools and they're more local. And then as you go to middle school, then it becomes like a bunch of primary schools feed into middle school. And then a bunch of middle schools feed into high schools. You know, so the schools are kind of getting larger. So you have like small local primary schools, bigger middle schools, and even bigger high schools. So that same pattern is in Mexico. So the primary schools are normally in person. They're normally not telesecondary. So that's why we're going to focus on this like 6 to 7 junction. There's also an important junction from 9 to 10 because that's when their high school starts at 10. Okay. All right, yeah, so you don't have to worry that they had that choice in previous years. So you'll just have like one test score for 6th grade. And I would suggest you enter it as a lag. So that's kind of controlling for everything that happened prior. Okay. So how you want to deal with the 2 test scores, you could just add them, you know, add math and Spanish, or you could do a separate analysis, like whatever you prefer. Okay. And I mean, if you want to go over the page limit, a little bit over is fine. The only thing, you know, I'm going to be grading these papers because it's not so easy for me to assign these projects to a grader, you know, because it's a little bit more, you know, you're not just looking for a right number. I'm actually, so it's going to require more grading from me, and I can't, if everybody writes a super long paper, I can't like grade so much. It'll just be really hard since our class is pretty big for me to grade, you know, I think we have 43 people. So that's why I'm hoping, you know, keep the papers rather a little shorter. Usually people like to write shorter papers, but so just kind of try to be succinct in your description. Okay, any questions? I mean, you might still have questions. I welcome your questions, and, you know, I'll try to, let's do it through Piazza. So if you have a question, you know, we can post it so everybody can follow, because other people might have the same question, you know, about the paper. So for now, I would suggest just look through some of the background papers, try to understand the Roy model that we did in class, you know, because you always have to have a good plan. Like before you start doing the estimation, you have to know where you're headed, you know. Okay. So in this project, it's a little bit different. So let me just say what's different from what we've been doing. So we've been dealing with this model here. Okay, and I think I mentioned in class that this is also used to evaluate effects of treatments. Okay, I mean, you could even use this to evaluate medical treatments. You know, like with this virus, they're trying to understand different drugs, you know, how different drugs would affect somebody. So why could be an outcome, you know, like how long you have this disease or whether you recover from it or how severe it gets. You know, and you could have people that are treated or not treated, or maybe treated with one drug versus treated with another drug. You know, so, I mean, unfortunately, it seems like right now there's, you know, not that much sophistication probably in what type of analysis they're doing. But if you did, my dogs are scratching at the door. Here. There, you're gonna hear scratching probably. Okay, so you could have this be two different drugs, for example, and this could be, say, the age of the person, or, you know, some characteristics of the person, like whether they had pre-existing conditions or something like that. Okay, but what we're gonna do with the schooling example is this is going to be telesecondary, and this is regular school. Okay, and then which one you go to. So DI equals 1. So in the Roy model, DI equals 1 if Y1 is greater than Y0, right? But in this model, there are going to be some additional variables because distance is a factor affecting choice of school. You know, if you live very far away from a regular school, you might be more likely to go to telesecondary. So Gabriel gave you 2 different distances to the different types of schools. So we want to allow for different variables here. Okay, so I'm going to call this ZI. So ZI gamma plus VI, where this can include the Xi's, but there might be some additional variables. Okay, so it's a slightly more general, this is actually called the generalized Roy model. Okay, and so let's look now, what is, because I asked you on the midterm to look at treatment on the treated. Okay, so here treatment is going to a telesecondary school. And the treated are people that have DI equals 1. Okay, so treatment on the treated, well, I'm going to call it delta TOT, okay? And that depends on your axis. So that would be the E of y1i minus y0i given xi and given di equals 1. Actually, you know, I think probably I should type some of this up and make a little handout or something. It is, I think I did, it is kind of in the notes. I don't know if it's exactly in this notation, but this is treatment on the treated, okay? And we already went over in class how to get these objects, but let's just like review it with the ZI, okay? Because now this model is slightly different because we have a VI epsilon 0, epsilon 1, and a V, okay? But the Roy model is nested in this. You know, if you didn't have any additional variables, the V could just be the difference in the epsilon. So this is just more general. So this is called generalized Roy model, right? All right, so let's just look at like how we would get this. So E of y1i given xi given di equals 1 is going to be xi beta 1 plus E of epsilon 1i given xi given v greater than or equal to minus di gamma. Okay, and then I normally like to standardize everything. Okay, I mean, you don't have to, but I think it just makes it a little easier to apply these formulas. And so then you just come up with the Mills ratio for this case. So it's xi beta 1 plus, so this is going to be sigma epsilon 1 v. It's a covariance because they're all mean zero. So it's just going to be, you know, this covariance. And then, let's see, over sigma v. And then this is E of v given v greater than or equal to minus di gamma over sigma v. Okay, so this is xi beta 1. I mean, I know this is a little painful when you first do it, but after you kind of get used to the formulas, it's not so bad. And then the labor supply model uses very similar formulas. Okay, so if you, okay, let's see, what is the symbol before this? This is, this is a subscript epsilon 1. I divided by this and multiplied by this just to standardize everything. That's it. Okay, and then this here would be the Mills ratio. So this is truncation from below, right? Okay, so that's the expression for E of y1i given xi given di equals 0, or sorry, di equals 1. All right, so you would estimate this equation. So remember the first step is just the binary probit. So from the binary probit, we're going to form the Mills ratio, and then we're going to run this regression. Right? Let's see. So when we run this regression, you'll get beta by itself. Well, so usually when you specify this model, let's say people are selecting which school to go to based on test scores, their expected test scores. So some of the X's are probably going to be in Z. So some of these would be in Z. So Z will include X, but it might also include things like distances. You know, because distances are costs of traveling, which would not affect test scores directly, but it would affect the decision to go, like which school you go to. So if there's some X's in here, okay, so let's say we're going to get some X's, some of the Z's are X's. Then when you get this beta, then you can back out the sigma V from the probit model. Okay, when we look at the labor supply model, I think it'll be totally clear like how this works. But if you have some variables that are in X and Z, you'll be able to actually back out the sigma B. Okay, because normally this thing will just be a coefficient in your regression. You know, so the question is, how are you going to get these individual components? All right. And so we would write down then, is it okay if I erase this? So this is E, well, maybe I'll erase the top part. So, because we also need to get treatment on the treated. So this is the E of Y1 given DI equals 1, okay? You know, I'll type this up in a little handout to give you so that you have a better idea of the model. You know, what you'd be estimating. Okay, then we have E of Y0I given Xi, and we also want given DI equals 1. Okay, because we want treatment on the treated. So, and treatment on the treated is this mean minus this mean. Okay, it's this minus this, because these are the treated. So I ask you on the midterm to come up with treatment on the treated. So that would be, you just have to write the appropriate control function. So, and this is a counterfactual. Like these people, you actually observe Y1. This group, you don't observe Y0, right? This is like the earnings for fishermen had they become hunters. Like that's the type of exercise we're doing. We're saying the earnings for people who go to private or who go to telesecondary school had they gone to a regular school. Okay, so this is what I called a counterfactual in the notes. Okay, so it's going to be xi beta 0 plus E of epsilon 0 I. So I'll divide this through to standardize. Okay, expectation given VI greater than or equal to ZI gamma over sigma B here. Sorry, so this would be like XI beta naught plus, so we're going to have sigma epsilon 0 V divided by, let's see, sigma V. And this is, again, the same truncation. So the Mills ratio is going to be the same. Okay. So this is the same as this, but this is different, okay? So I'll make a little handout to like, you know, give you some guidance how to get these things. All right, I mean, this you'll get, this beta hat, you'll get that from the regression when you use the DI equals 0 people. And then this is constructing the counterfactual, okay? All right, and so then you can figure out like what's the effect of going to telesecondary versus a regular school for the people who went to telesecondary school. Okay, that's okay. So it's really implementing the Roy model like as we did it. Okay, so so that's what I was going to say about the midterm, but I will I'll make up a little handout with these equations, you know, so that it's clear where to get these things. okay, like the sigma epsilon v and sigma v, because you do have to kind of back out some of these. Any questions or anything about the assignment? I mean, you have the whole month based, well, almost the whole month. I guess it's April 7th, so you have at least 3 weeks or so. I mean, I know you don't have a huge amount of time, so of course I'm not expecting to have like a super polished paper at the end, okay? Because it takes a while to do the analysis. But, all right. And you know, because you have this project, I'm not going to give a very long problem set. I'll just give you a couple problems to have a little experience with the material, like the last material, but the fourth problem set will not be like super hard, okay? I mean, I don't think any are super hard, but I'm gonna make it a little bit shorter, you know, given that you're working on this other project. I just wanna make sure you have a chance to, you know, get practice with the material before we have the final. Okay. And then the final is going to have more emphasis on the latter half, you know, since we didn't have a second midterm, I'll emphasize more the latter half of the class. Okay, so let's look. Now there are 2 topics I still wanted to do, and they're related to these types of formulas. So one is dealing with models with what's called censored data. Okay. Okay. And these are sometimes called Tobit models. They're named after James Tobin. He's a pretty famous economist. He was studying expenditure on durable goods. So for example, suppose you have a willingness to pay for a durable good. Like let's say willingness to pay for, what would be a good durable good? Air conditioner or something. Okay, you have some willingness to pay. So person I is willing to pay YI star for an air conditioner. Okay, that represents their willingness to pay. Oh, let me make it, I put it U, I'll just keep it how I have it in the notes. Well, in the market, you know, you only see air conditioners above a certain price. Like let's say there's no air conditioner below $150 or something. So you observe YI if YI star, so basically, well, you observe YI star if YI star is greater than or equal to Y0. And Y0 is min, in Tobin's example, it was minimum price in the market. Okay. You also can have this come up in other contexts, like I think I mentioned sometimes on surveys, they have a max, you know, like they don't report income above a certain level. It's usually for confidentiality reasons, because if you know the neighborhood a person works in and you know it's some really wealthy person, if you knew their exact income, you could find them in the data. Okay, so normally they'll have some sort of max where they don't report income above a max. So that's statistically, it's the same type of setup, okay? But Tobin's example was that there's a minimum price for a durable good, and you only observe how much people pay if it's above. All right. So what you do is you, and the goal would be, say, to get beta and to get sigma u. Okay. So we want to, and then we have di equals 1 if yi star observed. Okay, else di equals 0. And so you would solve this through maximum likelihood. So you basically have two types of observations. You have observations that are censored, and the censored ones are the ones that are below. Like if somebody was willing to pay $100 for an air conditioner, but there is no model at that price, you know, then you just see that they didn't buy one, okay? And then you have other people that actually bought it and you see what price they paid. That's the idea for the type of data that we have. Okay, so you solve it through maximum likelihood. So for the people that all you see is they didn't buy the good, okay, all we know is the probability that they don't buy the good is the probability that yi star is less or equal to y0. Okay, and 1 minus di means they didn't buy the good because we don't observe what they pay. Okay, and then for the other people that did buy the good, you want the density of yi star given that yi star is greater than or equal to y naught. Because for those people, you know what they paid. Okay, that was, so I'm assuming that there are different types of air conditioners, you know, and so they're luxury models, you know, I'm sure in reality you can pay $800 for an air conditioner if you want, or a window unit or something. I'm thinking like window units. Otherwise, if it's a home air conditioner, you can pay $20,000, actually, like those built-in units. But like a window air conditioner, there's a whole range, and then there's a willingness to pay, like say for different models. So, and this would be for anybody where we actually see that they bought one. Okay, so that's the likelihood. And if we write down this probability, well, we're going to assume UI is normal, mean 0, with some variance. So the probability that yi star is below y naught is the probability that UI is less than or equal to y naught minus xi beta. Okay, and then if you standardize, this is going to be, and you assume it's normal. Okay, it's just a probability that you didn't buy an air conditioner, this part. Okay. I mean, you could just do a probit model. Did you buy an air conditioner or not? Okay. And ignore what they actually paid for the air conditioner. So if you only did the probit model, you would only be getting beta over sigma u. That's what you would estimate. Okay, but if you actually use the data on how much they spent, you get more. Okay, that's, you can actually figure out what the beta and sigma u are separately. Oh, you know what? I forgot something. The board is kind of small. It makes it easy to forget stuff. So this should be, this is actually the times the probability that you did buy the air conditioner. So for people that you did buy the air conditioner, so this is so here is you bought the air conditioner and we see you spending a certain amount given that you bought the air conditioner. That's what this is. Okay, and this here, let's see. Okay, I will write down, so just keep note of what this is. I'll write this down over here so that we have more room. Okay, so this part here, the probability that it got censored, I'm going to write down over here because we need to have a little bit of room. Okay, those are people that did not buy the air conditioner. all you know is their willingness to pay was below Y0. Okay, now people who did buy the air conditioner. Okay, so you know that their willingness to pay was above Y0. So this is the probability they did buy the air conditioner. Okay, and now we need F of Y given that Y greater than Y not. So this is a conditional density actually. Okay, so we had, because the thing we're making the normality assumption is U. So let me write down what it is, and then maybe I can explain like where we get it from. But so the expression is not quite that bad because we actually get cancellation. Okay, this, and then this is times DI. Okay, so this is the whole likelihood. So this is the probability you don't buy the good. So your willingness to pay was below Y0. This is the probability you do buy the good. And then if you do buy the good, we observe your willingness to pay because we observe how much you paid for it. You know, let's say you bought a $300 air conditioner, then we see YI star, or this YI star actually. This is Y0. So this is the conditional density actually. This is the probability you see YI star given that YI star greater than Y0. And then it actually turns out that this cancels with this. Okay, so the overall likelihood is just this piece and this piece. Okay, and this is called a Tobit model, this type of model. So you can have censoring from below this. And what's the difference between like censoring and truncation? So there are two types of data you can have. You can have, if you see censored data, that means we actually see the X's for people that did not buy the good. That's called censored data. You could also have truncated data, and that means we don't see anything about people that didn't buy the good. Okay. So if I had truncated data, then the likelihood would not include this piece. In that case, the likelihood is actually only this ratio. But I didn't include that in the notes. I just gave you the case of censored data. So with censored data, we observe D1 and D0. Okay, and D0, we see the X's, but we don't see the Y because of the censoring point. Okay, and analytically, it would be the same type of setup if you had truncation from above. So maybe on your problem set, I'll give you, I just have to write a note to myself to remember this, but I will give you a question where you have censoring from above. So you can try out, you know, how you would write this down with censoring from above. And let me just give you a little intuition where that comes from, that expression. Okay, because when I see Y, so if I say like the probability that what I see YI star is equal to a certain amount, that would be the, well, not why not, because that was the censoring point. But let's say I see you buying some amount of goods. So probability I observe a certain YI star is going to be the probability that XI beta plus UI is equal to YI star, okay, which is the probability that UI is equal to YI star minus XI beta, okay. Yeah, so that's why here you see like yi minus xi beta over ui. I mean, it's not crucial to memorize these formulas or anything, but it's good to kind of get the general intuition for how this works. Like if you have censoring from above or censoring from below, because it's just more of a like data issue. Like you might actually encounter this someday. You have data and the data is censored. Like you don't see anybody, because it's kind of common that you might have this issue. All right. Now the last topic, well, we're going to spend the rest of this week working on labor supply models. And I actually think labor supply models are a little bit easier maybe than the Roy model. So, you know, hopefully, because the formulas are similar, you'll see the setup is slightly different from the Roy model, but all the stuff we've done already will carry over. So let me, markers seem to have a tendency to dry out a little bit. Let's see. So labor supply models. So this is, all these selection models that we've been talking about, labor supply models actually came before the Roy model. You know, this was the thing I told you, like Jim Heckman won the Nobel Prize partly for his work on selection and for showing these techniques of controlling for selection. So he has, you know, if you want, you could look at, he has some famous papers. I cite them in the labor supply section. But that's where really these techniques of including the Mills ratio and everything were developed, was in the context of labor supply. And if you ever take a labor economics class, you probably work on these types of models, but you may not work on how you estimate the model, okay? Because that's where really the econometrics comes in. So in the labor supply model, everybody gets a wage offer. So this little superscript means that's their offered wage. Sometimes this is written in logs. You might have a log wage instead of a wage offer. Let's see. So, wait, Omkar, so could you clarify, do you mean from the previous slide, what we observe and we don't observe? Or do you mean, from the previous slide, what we observed was, let's say you have data on everybody, their X's, and then you see, did they buy a refrigerator or not, or air conditioner? You know, did they buy some good? And then if they did buy the good, you see what they paid for it. That's the kind of data you have. If they did not buy the good, then you don't see what they paid for it. Okay, so that's the censoring. But in the context of like income survey, you might see everybody's income, but only to a top code. It's called top coding. You know, so let's say people that make above 200,000, they're just recorded as 200. Like there's the top code. So then it's similar. You only see their income, but if it's above a certain amount, then you don't see it. And that can be really important. Like if you wanted to study income inequality, you know, you'd have to take into account that there's a censoring. Like even if 5% of people are censored, that might affect your inferences about the income distribution. Okay, so it's kind of like a way that these formulas are used, you know, other than these different models. It's like another application. Maybe I should make it a separate section because it's almost like a whole separate topic. So this is like labor supply models. Okay, so in the labor supply example, you have a wage offer. Okay, and then you have what's called a reservation wage. And the reservation wage is the minimum wage that a person is willing to accept. Okay, so reservation wage. So it's minimum wage a person is willing to accept. Usually you don't know what that is. You know, there are a few surveys that actually ask people. There are a few surveys where they might say, oh, what's the minimum wage you would be willing to work for? And people might say, oh, $14 or something, you know, and then you actually see the reservation wage. But normally you don't know. Okay, so I'm going to proceed under the assumption that we don't have this. But the idea is, in these models, there's no voluntary unemployment. So this would be a really bad model for right now. You know, the unemployment rate has gone up and a lot of people are not able to work, you know. But in these models, these apply for regular times when the economy is not in bad shape, and people, the idea is people could get a job if they wanted one. Like there's always some employer like McDonald's or something. Everybody has a job offer, okay? But they may not accept it. You know, like maybe their best job offer is McDonald's, but their reservation wage is higher than the wage paid at McDonald's. So then that person would choose not to work, okay? So if we think about what belongs in X and what belongs in Z, so things that belong in X would be characteristics of the worker that are relevant for their wage. So XI, oh, see, how come this suddenly stopped working? XI is characteristics relevant for wage. Okay, so that would be things like your educational qualifications, maybe your labor market experience. And then it could even be gender and things, because it could be that there's discrimination or something, you know, so maybe gender or race might be important because there's some discrimination in the labor market, okay? Now ZI, those are characteristics, so those are characteristics relevant for your reservation wage. So that your reservation wage is like the value of staying home affects that. So characteristics relevant for reservation wage. So they're not necessarily the same. For reservation wage. So maybe your spouse's wage. So spousal wage. So when this was originally developed, you know, a lot of the people that stayed home were women, and so their husband's wage was important. Nowadays, you know, it's kind of equal. You know, there are men that stay home with the kids and the women go to work, you know, so. But when the original papers from the 1970s, it was usually husband's income that went here. And then another thing that might affect your decision to stay home is children, ages of your children. You know, what else? Actually, anything involving distance, costs of traveling to work might also be relevant. Okay. Okay, so those are variables. So, and some of these could overlap, because you may say people with more education have a preference for working. So some of the X's could be in Z's and vice versa. But usually there are a few things that go in Z that are not in X. Like you would not expect an employer to pay you a higher wage if your spouse makes more money. You know, like your spouse's wage shouldn't really be relevant for what your wage offer is. Okay. Yeah, unemployment benefits, that's a good question. So Ludo asked, what about unemployment benefits? Yes, unemployment benefits would affect your value of staying home. If you have very generous unemployment benefits, you might decide not to go to work. Okay, and unemployment benefits might vary regionally, right? There's actually a big literature about unemployment benefits and how that, I mean, usually they use more dynamic models, but they have like job search models where they look at the structure of unemployment benefits and how that affects labor market search decisions and working decisions. You know, because sometimes you have like, you might get a certain benefit for 1 year, then it drops to lower amount, you know, and at those points where the benefits drop, sometimes you suddenly see people looking for work. You know, so the structure of unemployment benefits and how that affects working is like a very traditional topic within labor economics, actually. Okay, so let's look at like statistically how we might estimate like this sort of model. So it's assumed you work. So work is DI equals 1 if the offered wage is greater than or equal. The equal, you know, since everything's continuous, you don't really have to worry about where the equal goes. But if the offered wage is greater than the reservation wage and you don't work otherwise. Okay, so it has the same structure. Like there's a model for whether you see the person working. And in this model, you only see the wage if people choose to work. So you only see the wage when people are working. So in some sense, this is easier than the Roy model, because in the Roy model, you had 2 outcomes, you know, the fisherman wage, the hunter wage. Here, you only see wages in one sector, the working sector, basically. Otherwise, all you know is that the person chose not to work. Okay, you don't actually see the level of the wage offer or the reservation wage. Okay, so it would be a problem if you only ran the regression for workers, because workers are a select group. Okay, so we can write this equation though. So this would be the wage equation. We're going to add and subtract the control function, like I did before. So the statistical techniques are the same, basically, compared to what we did. Okay, now this is like the new error term that has mean 0. So this is the control function. And this is that thing that's going to be a Mills ratio expression. This is needed to control for bias, control for selectivity bias. Control for selectivity bias. Okay. All right, so the crucial thing is we need to figure out what is this control function. And it's similar to, you know, what we've done already. So E of epsilon I given xi, now di equals 1, in this case is xi beta plus epsilon I is greater than zi gamma plus vi. That's what it means if di equals 1. It means your wage offer exceeded your reservation wage. Okay, and so we put all the observed variables on one side. So E of epsilon I given xi beta minus zi gamma is greater than vi minus epsilon I. Standardize this, okay. And then I also like to standardize those. I mean, I know in the end it usually cancels out, but all right, and so then we would get, so we'll have the covariance of epsilon I and vi minus epsilon I divided by sigma star, because this, so sigma star is square root of the variance of vi minus epsilon I. Okay, and then we need this Mills ratio expression actually. So times, this is truncation from above. This is like the CI that we had before. So we're gonna have times the CI, and this is 1 minus. Okay, so that's the control function, and this is the Mills ratio expression. Okay, and this covariance would actually be sigma epsilon V minus sigma epsilon squared over sigma star times this Mills ratio. Okay, so this is the control function. So that's what I would put in here. You know, so then I would run this regression. Okay, so I know maybe it's not all that easy to see on the board, but just tell you the regression I would run this regression. Well, these things dry out a little bit. Let me use green. I haven't used my green marker yet. I might have to buy more markers, but I'd run this regression. Okay, and this would be like that. Remember that this is the error term after subtracting this stuff off. So I'm going to put a tilde over it. Okay. So the first step would be I do a probit model for whether the person is working or not, like only using the working data. So just like with the Roy model, the first step is probit. So the first step is probit, work or not. Work or don't work. Like I don't use the wage data. I only use the data whether they work or not. And in the probit model, I include X's and Z's, you know, because both are relevant to the decision to work or not. Then in the second step, I do wage regression for workers, including Mills ratio. So including the Mills ratio is the control function. So I use the probit estimation to form CI, and then I run this wage regression. Okay, now what do I get from the second stage? Well, I get beta. That's the crucial thing that I get. Now I can use my beta and go back to the probit model, and then I can actually back out this, let's see here. See, I can get this. So if I have beta by itself, as long as I have some variables that are in X, but not in Z, I can actually back out the sigma star. Okay, and so once I have, so then I actually go back to probit. It's called a two-step, but at the end you go back to probit and you get sigma star. And once I have sigma star, I can also get gamma by itself. So I think I mentioned last time, the green is not super clear. Okay, here I can, let me write with, I have red. Let's see, we can try red maybe. These things, they seem to dry out, but then maybe after I keep the cap on, they're better. So let's see. Step one is probit. And it's only work or don't work. So I don't use wage data. That's the crucial. Step one, I'm not using my wage data. Step two is wage regression for workers only. With lambda function. So the lambda function is a control function. So from step one, I have the ingredients to get CI, then I can form the control function. Then I do my wage regression. And from that, I can get beta by itself. Like from the probit model, I get beta divided by sigma star from the probit. But now from the wage regression, I get beta by itself. Then I can go back to the probit model, then I get sigma star, okay? But that requires I have some variables that are in X, but not in Z. I'll go over this again next class because I know we don't have a lot of time. So it's an important topic, like exclusion restrictions. So exclusion restriction means I have some variables in X, but not in Z. Or it could be some variables in Z, but not in X. They're a little bit like instrumental variables. You know, I have some variables affecting, you know, the outcome here, but not affecting participation. Okay, they're called exclusion restrictions. But I'll go over all this next class. I'll kind of review this, so don't worry about it if it's not clear. Okay, exclusion restriction is, you know, when you have some in one set of variables, but not in the other one. So if I have one excluded variable, so something in X that's not in Z, then I can take this estimate of beta and I can get sigma star. And then once I have sigma star, then I can get gamma by itself, like not just gamma over sigma, I can get gamma by itself. So you have to do a little detective work kind of to figure out how to get all your parameters. Okay, so later, next class, I'll talk about like what kinds of policies would we like to do. Because once you have this model estimated, you can do interesting policy analysis. I mean, you could say, what if I increase wages for some workers? So we know like earned income tax credit is a government program that subsidizes wages for low wage earners. I mean, it has kind of a complicated schedule, but like suppose we had a simple schedule and you just gave low wage earners $2 extra per hour. You could say, how will that affect working behavior? How will that affect their wages? Okay, and then another policy you can do within this type of framework is you can say, suppose I change the tax rate, you know, and so I change taxes. So if I increase taxes or decrease taxes, you can analyze how does that affect working behavior? How does that affect the average wages for workers? Things like that. Okay, so but we're going to do all that stuff next time. So don't worry about, you know, it's just a preview. So quickly, we have a couple minutes. Does anybody, let's see, what question? What comes after the lambda function in the top right corner? Let's see. We don't have truncation from above. Let's see, we have truncation from above. So here we have truncation from above. Actually, this is correct. This CI, this is less than CI. So this Mills ratio should have a minus sign because when you have truncation from above, that should be a minus. Yes, very good. Very, very good that you, like I forgot the minus sign. So that shows me you really understand what's going on. That's good. Okay, and then, yeah, we assume all the errors are normally distributed, yes. Yeah, all these results, there are some, but we're not gonna cover it in this class. There are some models where you don't have to assume everything's normal, okay? So they're like semi-parametric sample selection models. There's a whole literature. So you can relax some of the normality assumptions, but it's kind of beyond what you would do, you know, in the undergrad class. Let's see, what comes after the lambda function in the WI0 equation? Oh, this is just the error term, but I put a little tilde over it because it's the error term after I subtract the control function. So remember the equation I erased? I had like epsilon 0 minus, or sorry, epsilon I minus E of epsilon I given given xi given di equals 1. That's what I'm calling epsilon I tilde. It's like there's still an error term, but there's no endogeneity problem. Okay, so that's what this is here, epsilon I tilde. Okay. Any other questions? Okay, so take a look, you know, after you hand in your problem set, take a look at the midterm assignment. I'm hoping that this will be kind of fun for you. I mean, I know maybe I have a warped sense of what's fun, but I'm hoping, you know, that you'll enjoy being able to be a little more creative in terms of the midterm project. And I know that you have a limited amount of time. You know, if you had like 3 months to work on a research project, of course it could be like more polished. And so, you know, I'm not expecting it to be like a huge polished paper, because I know you have other classes you're working on too. But I wanted it to be something where you could show your creativity and actually do some original research. Okay, so don't get like really stressed out about the midterm project. If it's like 5 to 10 pages or so, that's enough. Okay. All right. So, and if you have questions, just post them to Piazza, or you know, if you want to talk in person, just let me know. I'm happy to meet with you in person. I'm just at home every day, so my schedule is not very busy. Okay. Well then, thanks for coming to class, and I will see you on Thursday. And we'll finish with these labor supply models and look at different policy analysis you can do. Okay. All right. Bye.